Yes, good morning all dear students. Hope all of you are fine, doing well and great, and is putting consistent effort for your exam preparation. So last two to three classes we have discussed two chapter and one paper discussion, and in today's class we are going to discuss about a small chapter, that is periodic properties of element. So if you are ready for this class and have set up everything, book, paper and everything, we can start the class. If you are ready for this class, please put some emojis or thumbs up in the chat box so that I can take it as a positive sign to start the class. Yes, thank you for your response. Yes, so dear students, last class we have discussed the atomic structure chapter, but yeah, there are few questions as was there to do. I hope you have done it by yourself. If you have any doubt in that one, you can reach out to me personally, or now if you have any doubt with the question that I have taken in the atomic structure, you can just tell me about that one. I can solve that question now and I can move on. Anyone is there who got any doubt with any of the question that I have shared in the PPT? If nobody have doubt, we can start with the new chapter. Okay, so dear students, we are going to discuss about the new chapter, that is periodic properties of elements. And as we have discussed in the beginning of the orientation class, these are the important topics. That is, you can expect 1 to 2 questions from this chapter, and the important topics of this chapter are atomic and ionic radii, then ionization enthalpy, electron gain enthalpy, electronegativity, nature of oxides. These are the important topics that we will be discussing in detail, and this is a chapter which is coming as a base for the chemical bonding chapter, in which we will be discussing it in the next class. Okay, now we will see the first part of this chapter, that is the atomic radiation shielding effect. Atomic radiation shielding effect is a very important part because you can see a lot of questions from this part. If you check the PYQs, you can see a lot of questions from this part. Before telling about the trends and everything about atomic radius, I want to convey few things about this one, that is the basic things. What is total nuclear charge, what is effective nuclear charge, what is shielding effect. I hope all of you know what is total nuclear charge. Total nuclear charge means what? Nuclear charge is the total number of protons, or it is nothing but the atomic number. Okay, suppose I have an atom with a nucleus, and whatever the total charge present in the nucleus, which is due to the number of protons, that is what total nuclear charge. And this is a nucleus, and outer shell electron experiences this nuclear charge. But my question is the outer shell electron will be experiencing complete nuclear charge? Is the outer shell electron experiences the complete nuclear charge? Is that my question? Is it going to experience the complete total nuclear charge? No, right? Yes. Why? Because of the inner shell electron. Because of the presence of inner shell electron, the outer shell electron is not able to, yes, thank you Surabhi, is correct. Outer shell electron won't able to get the complete nuclear charge, and the charge experienced by the outer shell electron is what we call it as Z effective, or effective nuclear charge. And this Z effective will be equal to total nuclear charge minus total nuclear charge. I can write it as atomic number Z minus sigma.
Video is not visible.
Sorry, video is
not visible.
Okay, let me check the technical part. Subhash, can you please check my video is visible or not?
Nirmal, it's visible.
It's visible.
The students will check the internet.
Yeah, please check your network connection. Everything from our side is clear. What about other students? Are you guys feeling the same thing? Okay, I think it's from your part only, network issue. Yes, okay. So we can continue with the things. So total nuclear charge, it is yeah, effective nuclear charge is equal to total nuclear charge minus screening constant, and this much amount of nuclear charge will be absorbed, and the remaining only will be getting by the outer shell electrons. Okay, so now hope all of you got what is shielding effect. Shielding effect is this decrease in nuclear charge, the decrease in nuclear charge experienced by the outer shell electron due to the presence of inner shell. This inner shell is blocking the total nuclear charge in reaching the outer shell electrons. That is what shielding effect. Okay, and the equation is clearly mentioned here. Z effective is equal to Z minus sigma. Sigma is the shielding constant. Okay, hope that was clear to everyone. This is the basic idea. Now we will be going how this effective nuclear charge is affecting the atomic radius size. Okay, now we can go into that. Z effective. If the Z effective or effective nuclear charge is very high, which means if the electron experiences more nuclear charge, what is going to happen to the size of that shell? If that electron experiences more nuclear charge, the electron or the shell will becomes more closer to the nucleus, right? If it comes more closer to the nucleus, the size will decreases. So I can write Z effective is inversely proportional to the atomic radius. Okay, Z effective is inversely proportional to the atomic radius. That is why if I am going from left to right, what is happening? Z effective increases and atomic size decreases. And if I goes from top to bottom, what is happening to the Z effective? Is it increases or is it decreases? If I go from top to bottom, Z effective increases or decreases? That's my question.
Decreases.
Yes, very good. Z effective decreases. And what about atomic size?
Increases.
Yes, very good. Atomic size increases. This is the reason why the general trend of atomic size is going that is going from left to right, it will decreases, top to bottom it will increases. Okay, that's one of the point. Now another point I want to say is, what about the positive charge? That I will discuss when I am discussing about the isoelectronic species. This is the main idea behind the decrease in atomic size from left to right and increase in atomic size from top to bottom. But the major thing that you have to note down is exceptions in the atomic size. You can see one of the major exception in the 3D series, going from scandium to manganese, then from iron to nickel, and the last from copper to zinc. What is the order? I will be writing that over here. We know that going from left to right, that is scandium to zinc, atomic size should decrease, right? But there is some exception. But from scandium to manganese, it is in the correct order. Okay, from here it is in the correct order. The reason is Z effective is greater than shielding effect. Now if I am going from iron, cobalt and nickel. Iron, cobalt and nickel have almost same atomic size. What is the reason? From here onwards, the Z effective will be equal to the shielding effect. Due to that one, there is a similar atomic size if I am goes from iron to nickel. Now what about the next one? If I goes from copper to zinc, if you see, you can see an opposite trend. If you can see an opposite trend. What is happening in copper and zinc? Here the Z effective is lesser than shielding effect. That is, shielding effect dominates from copper to zinc. So this is the exceptional part of the atomic size. Okay, everyone have to note down this. You can expect a question from this part. And now one more exception that we can see in the boron family. Boron family, it is going from top to bottom, right? It is goes from top to bottom. What we are expecting? Expected. What is expected order? Boron, then aluminium, gallium, indium, thallium. Okay, what is the expected order? Boron will be having lesser, then aluminium, then gallium, then indium. But what is the actual order? Can anyone tell me? What is the actual order? What is the actual order? Who is going to tell me the answer? Actual order after boron, who is having the smallest size? Aluminium or gallium? Aluminium or gallium? Please give me a response. Or if you don't know, you can tell that. Guys, are you there? Or you start sleeping? Class has just started only. Don't fall asleep. Okay, yeah, I can see some reactions. Yes, fine. Okay, after boron it will be gallium, then aluminium, then indium, and then thallium. Here you can see there is a change. There is interchange of element here. What is the reason? Reason is due to transition contraction. What is transition contraction? Gallium, you can see the d orbital filling is starting in the gallium, and d orbital is having poor shielding. Due to that poor shielding, the outer shell will becomes more closer to the nucleus. Due to poor shielding, outer shell will be getting more nuclear charge. If the outer shell gets more nuclear charge, outer shell will comes more closer to it, and which will lead to the decrease in size comparing to the other. Okay, that is the reason. And what is the order of shielding effect? What is the order of shielding effect for orbitals? S, P, D, F. Which is having highest shielding power? I want answer from some of you here. Which is having highest shielding power? Dear students, give me the answer. S, P, D, F. This is a basic question. I think most of you are sleeping. Okay, I am getting answer from Surabhi, Hanuman Gowda. Yes, very good. S. First one is S. Then after that P. Then D. Then F. This is the order of, yes, very good. This is the order of shielding effect. Okay, this is the order of the shielding effect for orbitals. So these are the few points I want everyone to take a note of it. This is the important point and sure questions from this part, atomic radius. Total nuclear charge, FAT nuclear charge, shielding effect, and the general trend, exceptions. These are the two important exceptions I can say. Got it? If it is done, give me some reaction so that I can move to the next topic. Yes, thank you everyone for your response. Yes. Now we'll be moving into the next part. Yeah, that is isoelectronic species. This is another point I want everyone to take a note of it. Isoelectronic species. Isoelectronic species. What is isoelectronic species? These are the species in which they have same number of electrons. And for an isoelectronic species, the point I want everyone to take a note is, for isoelectronic species, atomic size is directly proportional to the magnitude of positive charge and inversely proportional to the magnitude of negative charge. This is the point I want everyone to take a note of it. Okay, sorry, just a mistake. Magnitude of negative directly proportional to the magnitude of negative charge and inversely proportional to the magnitude of positive charge. I can give you an example for that. Here, this is the example. O2 minus, F minus, Na plus, Mg2 plus, Al3 plus. All these have same number of electron, that is 10 electron. Now if you see how I can arrange them based on their atomic size, which is having highest negative charge, that is I mentioned here, which is having highest negative charge, that will be having highest size. Then first it is coming oxygen, then comes fluorine, then sodium, then magnesium, then aluminum. This is the order. This is the order. Okay, why it is happening is, we know that, example I can tell you, suppose an atom is having 12 proton and 12 neutron. Sorry, 12 proton and 12 electron. What I will be doing, I will be making that atom I will be making that atom an anion by adding one more electron, 13 electron, and I will be making the same atom a cation by removing one electron. Now this is the cation, this is the anion, and this is the neutral charge. Now you see why the cation is having lesser size, why the cation will be having lesser size. Here the 12 proton need to hold only 11 electron. 12 protons need to hold only 11 electron. So it can attract more closely towards itself. It can attract more closely towards itself, which lead to a lesser in size. Then comes anion. Anion means there comes one extra electron. There comes one extra electron. Because of that extra electron, the size becomes larger, because the 12 proton need to hold one more extra electron, which is a bit difficult for him. So the size will increases. Okay, is it clear? Is it clear to everyone? This is the important point. I want everyone to take a note about the isoelectronic species. Got it? Anybody want to explain it once again? Give me some reactions in the chat box. Yes, thank you Dhanashri, thank you Sangeeta, Prathamesh. Yes, what about others? Others are sleeping? Or are you getting bored? Okay, Namdev, yeah, thank you everyone for a response. Please put me a response, then only I will be feeling confident that you understood it and you are on track and everything. Yes, thank you all of you for your response. Now I want to move to the next part of it, that is ionization enthalpy. The ionization enthalpy is another important part. This is the rule breaker. This is the rule breaker in which you can see lot of exceptions. Anyhow, I want to tell what is ionization enthalpy. It is the energy required to remove an electron from its ground state gaseous atom. Remove an electron from the ground state gaseous atom to outside. That is what ionization enthalpy. It is energy required to remove an electron. That is what ionization enthalpy. And if the electron is more closely attracted to the nucleus, then we have to supply more energy to remove the electron. Which means I can make a relation here. If the Z effective, I can make a relation, that is, if the Z effective increases, or what is the relation between Z effective and ionization enthalpy? Higher the Z effective, ionization enthalpy will be lower or higher? Can anyone let me know in the chat box? Students, higher the Z effective, ionization enthalpy will be lower or higher? Yes, Surabhi, very good, it is higher. So I can say Z effective is, yes, Z effective is directly proportional to the ionization enthalpy. That is, higher the Z effective means that electron will be more closely attracted to the nucleus, which means we have to supply a big energy to remove that electron. And that, what is the name of that energy? That is ionization enthalpy. Okay. Now what is a trend? If I am going from left to right and top to bottom, going from left to right, ionization enthalpy increases or decreases? Yes. Ionization enthalpy increases or decreases?
No, please.
Yes, very good. It will increases, because going from left to right, Z effective increases, and which lead to the increase in ionization enthalpy. Going from top to bottom, ionization enthalpy increases or decreases? Tell me, guys. Yes, very good. It will decreases. This is the general trend. This is the general trend. But questions from general trend is very less. What from where the questions will be coming? Questions will be coming from the exceptions. And here I want everyone to take a note of the 2 exceptions in the group 2 element. Sorry, not group 2, period 2 element. Nitrogen, oxygen. Normally we will be thinking that oxygen will be having highest ionization enthalpy because oxygen is in the right side comparing to the nitrogen. But here nitrogen is having highest ionization enthalpy. What is the reason? Because of the half-filled configuration. Here you can see nitrogen is having a stable half-filled configuration. Due to the stable half-filled configuration, it is difficult to remove electron from nitrogen. But oxygen is not having a stable configuration, stable half-filled configuration. So if we remove one electron from oxygen, it can attain stable configuration. Due to that, removing that one electron will be difficult. So that is why ionization energy of nitrogen is greater. Now the same thing you can see in the case of beryllium and boron. Beryllium and boron. Beryllium it is 2s2, boron it is 2p1. Now here you can see removing an electron from boron is very easy because after removing it will be attaining a stable configuration. But beryllium you can see electrons are already in a stable state. Removing electron from this stable state is difficult. So that is why beryllium will be having highest ionization enthalpy than boron. Now these are the 2 important exceptions. Now I want everyone to take a note of the order of ionization enthalpy of second period. What is the order? And in the second period which will be having highest ionization enthalpy? Can anyone let me know? Which is going to have highest ionization enthalpy in the case of second period? Neon, fluorine, oxygen, nitrogen, carbon. Which is having highest? Fluorine. Surabhi is saying fluorine. Anyone else is having a different opinion? Okay. Actually, in the second period, the last element coming, that is neon, right? Neon is having the highest ionization enthalpy because neon is stable. Removing electron from this table is very difficult. Then comes fluorine. And after that there is a competition between nitrogen and oxygen. In that competition nitrogen will be winning. Then comes oxygen. Then there will be a competition between beryllium and boron. In that one beryllium will be winning and then boron and the last lithium. This is the order I want everyone to take a note because lot of question has come from this order. Least one is lithium, highest one is neon. Okay, take a note of it. Then fluorine, then nitrogen, oxygen. Okay, there is one missing one species here. What is that? Carbon is missing, right? Beryllium, boron, then comes carbon, then comes oxygen, then comes nitrogen. Okay, I will be writing it over once again. Highest one is for neon, then fluorine, then nitrogen, then oxygen, then carbon, then beryllium, then boron, then lithium. This is the order. Just take a note of it for the second period. Okay. Take a screenshot or take a note of it. If you're done with it, let me know. I will be moving on. Everyone done with it? Okay, thank you for your response. So question can ask from any part of this. They can give these 2, 3 or from any part of this series. Okay. Now this is all about the exceptions in the ionization enthalpy. Now one more thing I want everyone to take a note is successive ionization enthalpy. Successive ionization enthalpy will be always increasing. That is, third ionization enthalpy will be higher than second ionization enthalpy than first ionization enthalpy. Why it is happening is after removing an electron, that is the first ionization enthalpy, then removing one more electron will be very difficult because nuclear charge is remaining constant there. So when one electron is removed, nuclear charge can hold the remaining electron little more closely or little more tightly, so that will make high energy to remove the next electron, which means the second ionization enthalpy will be higher than the first ionization enthalpy, and then third ionization enthalpy. Okay, got it? That is what about successive ionization enthalpy. Are you clear? If you are clear with ionization enthalpy, we can move with the next part. Yes, yes, okay. What about others? Everyone? Yes, okay, chalo. We'll move to the next part. That is electron gain enthalpy. Another important part, it is electron gain enthalpy. Tell me guys, what is electron gain enthalpy? Electron gain enthalpy, it is the energy releasing when an electron is added to a neutral gaseous atom. As when electron is adding, here electron is adding, right? As electron is adding, what type of reaction it is? Exothermic or endothermic? Can you tell me, electron gain enthalpy is an exothermic reaction or an endothermic reaction?
Exothermic.
Yes, very good, Chris. It is exothermic reaction because energy releasing process it is. And my question is, I have an element X which is having minus 20 as the electron gain enthalpy. Electron gain enthalpy is minus 20 kilojoule per mole, and I have another element Y which is having first electron gain enthalpy, it is equal to minus 30 kilojoule per mole. My question is, among these two elements, which element I can add electron very easily? Which element I can add the electron very easily? Who is going to give me the answer? Or which element have more tendency to gain electron? Yes, Y. Yeah, Surabhi is saying Y, Chris is saying Y. Yeah, everyone is agreeing with Y, right? Very good. Yes, correct. Y have more tendency to add electron because it is having highest electron gain enthalpy. More energy will be releasing when I am adding an electron. If more energy releases when I am adding an electron, more stability will be there, because if more energy releases, the energy of system will decreases. If energy of system decreases, stability will increases. That is the main idea behind it. And this negative sign is saying that it is an exothermic reaction. That is the only thing. Got it? Got it, everyone? Yes. Now we can move into the general trend. What is a general trend? What is a general trend? Going from left to right and right to left. Left to right, electron gain enthalpy increases or decreases? Increase or decreases? Tell me guys.
Decreases.
Decreases or increases?
Increases.
Yes, very good. It will be increases. And going from top to bottom, electron gain enthalpy, it will increases or decreases?
Decreases.
Yes, decreases. That's the point. Okay. Now there are exceptions. The first exception I want everyone to take a note is exception the halogen. Normally we will be thinking that fluorine which will be having highest electron gain enthalpy, but due to the high charge density and repulsion to the electron, fluorine will be having lesser electron gain enthalpy comparing to the chlorine. And what is the order? Chlorine will be having highest among that halogen, then fluorine, then bromine, then iodine. This is the order for halogen. Okay, this is the order for halogen because fluorine is having high charge density, so it will repel the incoming electron. Due to that repelling, the electron gain enthalpy value will be less. Now what about chalcogens or oxygen family? What about oxygen family? What is the order? Who is going to give me the answer? Order of electron gain enthalpy of chalcogen. Which is having highest? Highest is having which one? Yeah, highest is having sulfur. After sulfur, my question is, after sulfur, who is having the highest electron gain enthalpy? Who is going to give me the answer? Is it oxygen or is it any other element? Anyone? Or shall I tell? Simply you can guess, no one is going to tell anything. You can guess it. Nobody want to give guess? Now you won't guess, but in the exam you will guess a lot. Okay, yeah, I will be only telling that. After sulfur it is not oxygen. After sulfur then it is selenium, then tellurium, then polonium, and the last is coming oxygen. Here it's a main point you have to note is sulfur is having the greatest and oxygen is having the least. But in this case, after chlorine, fluorine will be coming in the second position. These are the 2 points I want to take a note. Yes. Same reason, the reason is same. But here in the case of oxygen, the repulsion is little bit higher than the repulsion experienced by fluorine. That's only the difference. Yes. Are you done? Are you done by taking note of these things? If that is the case, we can move. This is the short idea about electron gain enthalpy and the important exceptions. Yes. Okay. Hope everyone understood this one, and now we can move. Then the last part, the second last part, that is nature of oxides. Nature of oxides. Nature of oxides, easy questions only will be coming. Only thing that you have to take a note of few points. What are the few points? Oxides I can classify it into 3: amphoteric oxides, neutral oxides, and basic oxides and acidic oxides. Okay, these are the few oxides I want everyone to take a note of it. What is amphoteric oxide? It will react with both acids and bases. Amphoteric oxides you should remember. You should remember amphoteric oxides. This is going to be the one who is going to predict the correct answer. Amphoteric oxides, because acidic oxides and basic oxides you can identify using a concept. What I can tell you, I can give you a simple idea, simple trick how you can remember the amphoteric oxides. The metals of the oxides of the following metals are amphoteric. Which are the metals? First one is aluminium, then tin, then zinc, then lead, then beryllium, then vanadium, chromium, manganese. It is MnO2. Take a note of these metals. These metals oxides are always amphoteric. How you can remember it? You can just remember it by using some mnemonics. What? Aluminium, Sn, Zn, Pbb. You can remember like Alison Pabe. You know who is Alison Pabe? I don't know. Imagine there is some person called Alison Pabe. Aluminium, Sn, Zn, Pbb, and Vicrumen, vanadium, chromium, manganese. Just remember this mnemonic, and you can remember the amphoteric oxides. Got it? Alison Pabe, Vicrumen. Okay, just remember that. You can remember the amphoteric oxides. And manganese, it is MnO2. MnO2 is the amphoteric oxide. Remaining are acidic and basic depending upon the oxidation state. Okay. Now what about neutral oxide? Neutral oxide, only you have to remember these 3: carbon monoxide, nitric oxide, and N2O. These are the 3 neutral oxides. You have to remember these 3 only. No, nothing else you need to remember. Okay. Carbon monoxide, CO, NO, N2O. CO, NO, N2O. That is the one you have to remember. Okay. Now what about basic oxides and acidic oxide? Basic oxides are metallic oxides. If you see oxides of metals, then they will be they will be basic oxides. And if you see oxides of non-metal, they will be acidic metal. That is the point. Got it? Now I hope all of you can solve any questions from this part. Amphoteric, remember these metal, allicin, pabe, bichromine, remember that mnemonic. And neutral oxide, these three only you have to remember. And metallic oxides are basic, non-metallic oxides are acidic. These are the points. Is these points are clear? Are you all noted down everything? If that is the case, we can move. Yes, thank you all of you for your response. Okay. You can take a screenshot, and anyhow I will be sharing this PPT, but annotations you have to write it in your notebook, because PPT that won't be there. I will try to get that. If I got it, I will be sharing that also. Okay, now the last part I want to take everyone to take note is diagonal relationship. Second period element shows similar properties to the third period elements diagonally below them. Lithium will be showing similarities with the magnesium. Beryllium will be showing similarity with aluminium. Boron will be showing similarity with the silicon. Remember these pairs. If any questions asked, you can answer it very easily. Okay. Yes, the reasons are similar ionic potential. These are having almost similar ionic potential or charge by size ratio. That is the reason why second period elements show similarities with the third period element diagonally. Okay, got it? Now the things are over. The important points of this small chapter is over. Now we are going to do the questions, and through questions we can add few more points. Now after seeing the question, definitely you will become confident, because whatever the concept I have taught you, the questions has come from that part only. Okay, additional points from this I will be adding it while solving the question. Are you done? Are you guys are clear about all these concepts? Shall we go for the questions, PYQs? Yes, thank you all of you for your response. I will be taking the PYQs like for half an hour. After that we can move into the chemical bonding chapter, because chemical bonding chapter is a little bit lengthier chapter. 1.5 hours is not that sufficient, and I will take a 50 minutes of chemical bonding chapter today, and the remaining part I will be continuing it in the next class. Okay. Yes, here is the first question for you. It is a NEET 2025 question. Which of the following statements are true? Yeah, now is the time. It's a time for the competition. Who is going to give me the answer first? I will be reading out the question. And in periodic property, one thing is that there are questions in which informative questions in which you have to by heart it, and you have to by heart it or you have to remember it. That's the thing. That points also you have to make it as a note. First one, unlike gallium that has a very high melting point, cesium have a very low melting point. That is the first one. Are you going to agree with this? This is the informative one. This is the informative statement. Anybody know about this one? Is it correct or is it wrong? Yes, very good, Prathamesh. It is wrong. Okay. Why it is wrong? Both gallium and cesium have low melting point. Gallium, it is having low melting point because gallium will be existing as dimer Ga2, and they are existing with the help of weak van der Waals force. As they are combining through weak van der Waals force, it's very difficult to break them, or it is very difficult to melt them. And this gallium is also called as hand melting metal. What is hand melting metal? Yes, sorry.
Option 2.
Option 2. Yeah, option 2 is the correct one. Very good. Anybody have objection with any other options? No, right? Yes. And it is hand melting metal. If gallium, if I place it in my hand, it will melt. That temperature is enough. Around room temperature is enough for melting gallium. And why cesium is low melting point? Because of its high size. Because of its high size, it won't be properly involved in the metallic bonding. As it is having a weak metallic bonding, it can easily be melted. Now what about second one? On Pauling scale, the electronegativity values of nitrogen and chlorine are not same. Is it correct? Did I mention? Just give me a minute. I think I missed electronegativity part. Let me see that. Okay, sorry guys, I missed electronegativity part. Yeah, this is the one point to take a note. There is nothing about electronegativity. Electronegativity is nothing but sharing, hunger for the electron, hunger for shared electron, tendency of an element to attract the shared pair of electron towards itself. Okay, and Pauling scale, I want everyone to note few elements. Electronegativity. Fluorine is the highest in the periodic table with the electronegativity. The highest electronegative element in periodic table is fluorine. Then comes oxygen. It is not fluorine. Sorry, it is not chlorine. Then comes oxygen, which is 3.5. Then nitrogen and chlorine, it is 3.0. We can, yes, anybody saying anything? Gayatri? Yeah, Gayatri, are you saying something? Are you saying something? I can't hear you properly. Or is it by mistake? Please unmute yourself. Sorry, please mute yourself. I can't hear you. Can you put a message? Your voice is not audible. You are saying screen is small? What is your query? Screen is not clear. Is it happening for everyone? Is it happening for everyone? If my screen is visible properly, please put me in the chat. Visible, right? Okay, so Gayatri, please check your network connection. Maybe due to poor network only it is not clear. Okay. Yes, thank you everyone for your response. Okay, so electronegativity, fluorine comes higher, then oxygen, then nitrogen and chlorine. Nitrogen and chlorine have same electronegativity. You can remember this mnemonic, phone call. Highest is for fluorine, then oxygen, then nitrogen and chlorine same, that is 3. Phone call. Okay. Now using the electronegativity value, we can predict whether the compound is polar, non-polar or ionic. How we can? Electronegativity difference will be telling you. If the electronegativity difference delta En, if it is greater than 1.7, that is, here you can see if electronegativity difference is greater than 1.7, then it is ionic. And if it is 0 or if it is lesser than 0.4, if it is lesser than 0.4, we can say it is covalent. And if it is in between 0.4 and 1.7, we can say they are polar. Okay, if it is less than 0.4, it is non-polar covalent. Okay, if it is between 0.4 to 1.7, it is polar. If it is greater than 1.7, we can say it is largely ionic. Okay, is it done? Okay, these are the points you need to note down in electronegativity. Okay, now we can go into the question. Yes, on Pauling scale, the electronegativity values of nitrogen and chlorine are not same. Is it not same or is it same? Just now only we discussed chlorine and nitrogen, not same or same? It is same. So this is not the correct one. This is also not the correct one. What about this one? Argon, krypton, chlorine are all isoelectronic species. Are they isoelectronic species?
Yes, sir.
Yes, they are isoelectronic species. What is the number of electrons? What is the number of electrons? What is the number of electron? Tell me. Very good. It is 18 electron. Now coming to the option D, silicon, aluminium, magnesium, sodium. Is it the correct order or is it the wrong order? Is it correct or wrong? Okay, I think there is it is wrong. Are you sure it is wrong? Are you sure it is wrong? I said the exceptions are there in the second period but not in the third period. Okay, what is the order? Here you can see if I am going from left to right, sodium, then comes magnesium, then aluminium, then silicon. Okay, here even though, sorry,
enthalpy is wrong.
which one? You are saying D is wrong, or okay, let me explain this one. This is going from left to right, right? Left to right, ionization enthalpy will increases, which means silicon will be having higher, then comes aluminium, then comes boron. This is the order. You can see, is it the same order? Yes, silicon comes first, then aluminium, then magnesium, then sodium. This is the correct one. Here there is no exception, because experimentally the value of first ionization enthalpy of ionization aluminium is greater than magnesium. But there is an exception in the second period, but in the third period there is no exception. This is the correct statement. Okay, so option D is correct. Then any other option? Atomic radius of cesium is greater than lithium and rubidium. Is it correct? Lithium and rubidium, is it correct? Yes, of course, cesium is in the bottom. Cesium is in the bottom of the periodic table. So this is correct. So what is the answer? D and, yeah, D and
Option 4.
option, okay, yeah, this is also correct. D,
Option
D,
4.
yeah, option 4 is the correct. No, not
No,
option.
sir, no, sir.
I think there is some mistake in the option, I guess. D is correct. C is correct. Option E. Cesium is greater. Cesium, you have atomic radius greater than rubidium. I think the options are given are wrong. First one is false. Then the second one is correct, right? Sorry, second one is wrong. Then the third one is correct. C is correct. D is correct. E. C, D, E. C, D, E. I think that option is not there. Okay, I think this option I have mentioned it is wrong only. I will correct it and will give you the new correct option. C, D, E is the correct one. Okay, you can take it. Or what about C and D? I think cesium. Yes. Yes. C, D is only correct one. Okay, this is not the correct options of this question. Sorry for that. Okay. So these are the points of this question. Now I will be moving to the next question. Okay. Yes. Yeah, here is another question which is NEET 2025 question. NEET 2025 question. Tell me, who is going to give me the answer first? Which among the following electronic configurations belongs to main group elements? Main group elements. Option A, B, C, D. Main group elements. Which are the main group elements? Main group elements are S and P block elements. How we can identify that it is S or P block elements? How we can identify that it is S or P block element? If the last electron enters into the S orbital or P orbital, then we can say that it belongs to either S orbital or P, S block or P block elements. And electron option
A and C.
A and C. Okay. Prathamesh is saying option A and C. What about others? Are you got the same thing? Others, you got the same? Yes. Yeah, very good. Option C, A and C is the correct one. Option A and C is the correct one. And how we can understand that this belongs to S? Here we can see last electron belongs to the S subshell, so it is S block. Here we can see last electrons will be entering into the D orbital, because according to the Aufbau principle, the highest energy is 3D only. 3 plus 2 it is 5, but for us it is 4 plus 0 it is 4. Last electron will be entering into that shell which is having highest n plus L value. Okay. Now what about for C? It is entering into the 5p. Now what about for here? 3d10 4s1. Last electron is entering in the D orbital, because 3D is having highest n plus L value. Then what about here, last one? Here the highest n plus, yeah, activated series, so it is F block element. Okay, so these are the different blocks belongs to this particular electronic configuration. Okay, is it clear everyone? Can we move to the next question? Yes. Okay, now we'll move to the next question. Yeah, another question from NEET 2024. Correct decreasing order of atomic radii of lithium, beryllium, boron and carbon. Very easy question. Atomic radius. This is following a general trend. This question we can say it is following general trend. Option D.
Option B.
B, option B, yes, very good. Option B is the correct one, because it is following general trend. There is no exceptions in the atomic radii if I goes from lithium to carbon. Carbon is in the right side, then comes boron, then beryllium, then lithium. Lithium, beryllium, boron. It is following the left to right general trend. So this is the order of atomic radii. Okay, we can move to the next question. Yes, here is the next question for you. Give me the answer. Nitrogen atom. Among these, which one you think that which is matching properly to the nitrogen atom? Nitrogen atom, paramagnetic, more relative elements in, more reactive element in, okay, it's not relative, it is reactive, most reactive element in group 18, element with the highest ionization enthalpy in group 15, and the last option is strong oxidizing agent. Tell me which one is going to match with nitrogen. Tell me students, which one is going to match with nitrogen? Of course, by looking. Yes, very good. It's by clear that it is the highest ionization enthalpy in group 15. Now what about fluorine? What about fluorine? Among these, which one is going to match with the fluorine? Which one is going to match with the fluorine?
Strongest oxidizing.
Yes, very good. Fluorine, we know that it is an electronegative. It is an electronegative element. As it is an electronegative element, it can gain electron. Gaining of electron is the process of reduction. If any element which is acting as which is undergoing reduction, that will act as oxidizing agent. So fluorine is an oxidizing agent because it will undergo reduction by gaining of electron. Now what about oxygen? Oxygen is having 16 electrons. Yes, it is paramagnetic. Oxygen is paramagnetic. That will be getting through MOT, molecular orbital theory. We will be understanding it, in which we will be discussing it in the next class. Okay, now what about xenon? Now the last one is xenon. Xenon is the most reactive element in the group 18. Xenon is most reactive element in group 18 because xenon is in the top. Xenon is in the bottom. As xenon is in the bottom, it is having least ionization energy. As it is having least ionization energy, outer shell electron can easily participate in the reaction. So it is most reactive in group 18. Okay, so these are the questions. Shall I move everyone? Yes, we'll move to the next question. Yes, another one. This is the question in which you have to take a note of it. I will be sharing the answer. This is actually a JE question, JE MCQ question, in which has mentioned four exceptions of boron family. Boron family is the family which is showing more number of exceptions. If anybody got the answer, you can let me know. Option A, B, C, D. Let me see the chat box. I think using the option D, then Yusri is saying option D. Okay, we can see. Yes, any other options? I think using the options you can understand. Maybe you are not familiar with everything in this, but you are familiar with one thing. What is that? Atomic radius. Atomic radius, which is the D, in which D have different. In the options you can see D is matching with a different list in the list 2. Different options in the list 2. Atomic radius order of boron family. What is the atomic radius order of boron family? Boron is having highest, then comes gallium. Gallium will be overtaking aluminium, then indium, then thallium. So I can match D with the, yes, very good. Option
B, second.
Option B. How it can be option B?
Second. Option A.
Option D is matching with the fourth, which is the last one. Option D is matching with the third one. So option A. There is no other options. There is no other options. You can see D is matching with the 3. Got it? So you can go with the option A. But another point is that question can ask from these 3 points. Question can ask from these 3 things. So you have to make a note of it. Melting point order. Melting point order is matching with the fourth one. Boron, then aluminium, then indium, then boron, aluminium, thallium, indium, then gallium. That is the melting point order. What about the ionic radius? Ionic radius is M plus 3. That is after removing third electron. What is the order of ionic radii? That is following the normal trend. Boron, then aluminium, then gallium, then indium, then thallium. M plus 3 ionic radii of boron is following general trend. That is the top to bottom trend. Now first ionization enthalpy, option C. That is boron, then thallium, then aluminium. Aluminium and gallium have same, almost similar ionization enthalpy. Then indium. So these are the points I want everyone to take note, because question can ask. This is the important exceptions in the boron family. I will be writing that over here. Just write it. Yeah, just take a note of it. Write it in your notebook. And you should revise this order every day. Is the screen is visible? Can you all able to write it? Yes, thank you. Write it. Everyone should write this order. If it is done, give me a thumbs up. I will be moving to the next question. Okay, I think everyone has done this. Okay, yeah. Okay, write it. Guys, I am thinking to start chemical bonding right now. What's your opinion? Or shall we move with the remaining questions of periodic properties? Just unmute and tell me what's in your mind. Should we continue with the remaining questions in periodic properties, or shall we go with the chemical bonding chapter? 5 more minutes. 5 more minutes for what? For the chapter, right? For this chapter. After that we can start chemical bonding. That is what you are saying? Okay, we can. Okay, yes. Thank you for response. 5 more minutes we will do the questions. Yes, 5 more minutes we can do the question, and after that we can start the chemical bonding chapter. Yes. Okay, I think everyone has taken a note of it. We'll be moving for the next question. Yeah. Here is a question for you. Arrange the following elements in increasing order of first ionization enthalpy: lithium, beryllium, boron, carbon, nitrogen. I have given this order in the class, in the conceptual part.
Option B.
Option D. Yeah, we know that. B. Okay, option B. B for beta. Yes. We all know that nitrogen is having the highest because of stable half-filled configuration. Then comes carbon, then comes beryllium. Beryllium will be overtaking boron. Then lithium. This is the order. I have given all the complete order of second period element. So this is the answer. I hope everyone has got this one. Yes, we'll be moving to the next question. Yes, please stay online till the end of the class. I know like it's difficult, but you should be there till the end of the class, then only you will be getting the complete idea of this chapter. More PYQ solving, more idea will be getting. Okay, arrange the following elements in the increasing order of electronegativity. Give me the answer for this. Electronegativity it is asking. We know that in the periodic table,
Option A.
option A, yes, very good. In periodic table we can see fluorine has highest electronegativity and chlorine has highest electron gain enthalpy. This difference you should know. Fluorine highest electronegativity, but when it's coming to the chlorine, it is having the highest electron gain enthalpy in the periodic table. Okay. Yes, so option A is the correct one. First fluorine, then oxygen, then nitrogen, then carbon, silicon. Carbon, silicon going from top to down. Electronegativity decreases. Shall I move for the next? Yes. Yes. Yeah, here is another question in which it can confuse you. Give me the answer, everyone.
Option D.
Option D. Okay. Sangeeta is saying B. Beta or delta? Beta. Okay. Sangeeta is saying option beta is the correct one. Anyone else who is going against with the Sangeeta?
Option C.
Option C, yes. Prathamesh is going opposite to the Sangeeta, that is acidic oxides, option C. Anyone else is opposing both of them? Simply oppose, no problem. Option B.
Sir, option D.
Option D. Chris is saying option D. Okay, I am getting options, all the options from you. Anyone is saying option A? Someone please tell option A so that we can go with all the options. Option A, anyone is going with option A? No one? Okay, so your options are B, C and D. Now we can see which one is going to be the correct one. Acidic basic oxides. We know that basic oxides are metallic oxides. Basic oxides are metallic oxides. We know that indium is coming as a metal, potassium is coming as a metal, but SN, what is SN? Amphoteric oxide. So this is not going to be the correct one. In the mnemonic we have discussed Alice and Babe, in that zinc and SN, that is tin. Both oxides belongs to the amphoteric oxide. Now what about B? I know what is your confusion. Carbon, nitrogen, okay, carbon monoxide and nitrogen oxide. That is what you have seen in the class, right? But you should be very clear that it is carbon monoxide and N2O. Carbon monoxide, N2O and NO. These three are the neutral oxides. NO2 is not a neutral oxide. It is carbon monoxide, nitric oxide and nitrous oxide, N2O. Got it? Got it everyone? Tell me guys. Yes.
Yes, sir.
So this is the mistake that you will be doing. You will be thinking that these are neutral oxides, but it is NO, CO and N2O. Now what about the C, option C? Who has given the option C? Few of you have given option C, right? What is the thing you should note down in option C? Option C, acidic oxides are non-metallic oxides. In this you can see sulfur is a non-metallic one here. Remaining manganese and tellurium are having more metallic nature, or they can be a metalloid. But why they comes in the acidic nature, acidic oxide? Why they comes in the acidic oxide? It is because of the high oxidation state. We have to write one more point. Oxidation state is directly proportional to the acidic nature. Oxidation state is directly proportional to the acidic nature. Here you can see manganese is Mn2O7. Mn2O7 is in plus, it is in +7 oxidation state. As it is having highest oxidation state, because of its highest oxidation state, it can receive electrons. Or highest oxidation state means it is having vacant orbital. If it have vacant orbital, it can receive electrons. Receiving electron is what the tendency is, what tendency? Acidic nature, right? Donating electron is basic nature. So that is why MnO2 is a acidic oxide. Same the case of tellurium trioxide. Tellurium trioxide, it is having +6 oxidation state. Okay. So due to the high oxidation state, it will be acting as acidic oxide. So this is our correct answer. And amphoteric oxide, if you observe, beryllium oxide is amphoteric. Remaining two are not, and amphoteric oxide. Understood? Few more points we have discussed about oxidation state, that is, about the acidic nature and basic nature, that is oxidation state. Higher the oxidation state, higher will be the acidic nature. Is it clear, everyone? Is it clear? So what's your opinion? Shall we start the new chapter or shall we continue the questions? You have to stay online, that's the thing. I can see people are leaving because maybe you are tired. Okay. Or we can go with one more question and then we can go for the next chapter. NEET 2023. Give me the answer. Neutral, acidic, basic and amphoteric oxide. Remaining questions I will be sharing in the group with the explanation also, so that it will be easy for you to understand the things. Okay. Give me the answer quickly. Neutral, first should be neutral, then acidic, then basic, then amphoteric. Which are the three neutral oxides? Which are the three neutral oxides? Carbon monoxide, NO and N2O.
NO2.
Yeah, so here we can see the option. Which are the options that we can ignore? First, option B we can ignore. Option B we can ignore. Okay.
D.
Okay, option D is the correct one, you are saying, right? We can see. NO is a neutral oxide. Yes, correct one. Then acidic. Carbon dioxide, it is acidic because it is a non-metallic oxide. Then basic. Basics are metallic oxide. Calcium oxide. Calcium is a metal, so it is a metallic oxide. Metallic oxides are basic in nature. And ZNO, zinc, we all know that it is amphoteric in nature, so option D is the correct one. Very good. Done, everyone? Are you okay with this chapter? Now you solve the question. I am very sure you can able to solve most of the questions from this chapter. Remaining questions I will be sharing it in the group. Go through it and have a good grip of this chapter. Now, dear students, are you ready for the new chapter? I know, like in the last moment starting a new chapter, it's not good, but yeah, the situation is like that. 1.5 hours is not that much sufficient. I need to give more content for the chemical bonding because it's a high weightage chapter. Okay, so please be online. We will be starting the new chapter very soon. Yes, the new chapter is loading. Wait for it. So people, how you are feeling? Are you able to solve the questions? Are you getting some confidence? Or if you have any suggestions in the chemistry, you can tell me. I can move with that. That is, I should slow down myself. I know I am going a little bit faster because it is a crash course. We need to cover more content in a short period of time. Any other suggestions if you have, you can let me know. Have any suggestions, anyone? Nobody? Please speak to me, guys. I want to talk to you. I know it is an online class, but because of some limitations I am not able to talk to you individually. But if you open up yourself, yeah, I will be feeling good. Yes. Have any suggestions, anyone? Anyone have any suggestions? That it will be good if I... No. Okay, thank you, Prathamesh. Anyone else? It will be good that if we go like this or like that. Okay. So, welcome all of you for the new chapter. Here we will be starting the new chapter. Please be patiently wait. Yes. So, dear students, chemical bonding, one of the high weightage chapter and easy scoring chapter. Why I am telling it is, most of the questions from this chapter you can solve it using the tips and tricks that I will be explaining it here. Okay. So, we will be starting with the important topics of this chapter. Which are the important topics? VSEPR theory, hybridization, molecular orbital theory, dipole moment and Fajan's rule. These are the important topics in which I will be covering it. Okay. So, the first topic that I will be covering it is about the octet rule. Octet rule also question has come, that is why I have added this slide here. Okay. In the octet rule, what is? Atom gain, lose or share electron to achieve stable ns2np6. Stable ns2np6. And the question, the NEET favorite is exceptions. What are the exceptions? Exceptions are incomplete octet. There are compounds which is having incomplete octet like lithium chloride, beryllium hydrate, boron chloride. These are the one which is having less than 8 electron. Less than 8 electron. Lithium chloride is having 2 electron, beryllium hydride is having 4 electron, boron chloride is having 6 electron. They are electron deficient species. Okay, and they are not following the octet rule, but still they are stable. And another one is expanded octet, PF5. PF5 is having 10 electron, then SF6 is having 12 electron, IF7 14 electron, H2SO4 is also have 12 electron. So these are the expanded octet configuration. Then odd electron species, NO and NO2, they are having the 5 electrons. So these are the species which we can say exceptions of octet rule. Okay, and it's a very easy question only. I will give you the question that has come in the NEET exam. Shall I give you the question? If you see any compound which is not following 8 electrons in their valency shell, they are exception. Shall I give you a question? Can you do it? Yes, you can do it, definitely. Yeah, give me the answer. Give me the answer in the chat box or unmute yourself. Open up yourself. I want answer from everyone. Not having 8 electrons around the central atom. Not having 8 electrons. NH3, aluminium trichloride, BeCl2, CCl4, PCl5. Tell me the answer quickly in the chat box. NH3, is it following? Option D. Yes, who is Kiran has given option D. Yes, Kiran. Anyone else? Anyone else is option D. Yes, I think everyone is going with the Kiran only. Anyone else is opposing Kiran? Yes, I think everyone. Yes, very good. Yeah, option D is the correct. That is 3. Aluminium trichloride, it is having 6 electron. NH3 we all know that tetrahedral, it is having 8 electron. BeCl2 4 electron. CCl4 8 electron tetrahedral. PCl5 10 electron. So among these which is not following the octet rule, how many are there? Yes, 1 2 3. That is option 3 is correct. Okay, so this is the easiest question coming from this part. Now next one. Now the important topic is ionic bonding. Ionic bonding and lattice enthalpy. Okay, what is ionic bonding? That is what I want to know from your side. Ionic bonding. How an ionic bond is forming? Ionic bond is formed by the complete transfer of electron. Ionic bond is also called as valent bond and is also called as non-directional bond. Ionic bond is also called as electron valent bond or non-directional bond, and it is happening between which elements? It is happening between metal and non-metal. That is a condition you have to note down. It is happening between it is happening between good metal and good non-metal. It is happening between good metal and good non-metal. What is meant by good metal? Good metal means what is a condition or what is a property of a metal? It has to lose electron, it has to donate electron. So which metal can donate the electron very easily? That metal which is having less ionization energy. So low ionization enthalpy of metal and high negative electron gain enthalpy of non-metal will make a good ionic bond. Metal will be donating electron and that donated electron will be received by non-metal. To receive the donated electron from a metal, non-metal should have high electron gain enthalpy. That is what about ionic bond. Is it clear, everyone? Is it clear? Okay. Now lattice enthalpy. What is this lattice enthalpy? If I am making an ionic compound, how I will be making an ionic compound? I will be taking cation, I will be taking anion of it. They will be coming together through the electrostatic force of attraction, and the energy released when they comes closer to each other, that is called as lattice enthalpy. And lattice enthalpy will be telling you the strength, of an ionic bond. Higher the lattice enthalpy, higher will be the strength of ionic bond. And how we can understand the order of lattice enthalpy? Lattice enthalpy is directly proportional to charge and inversely proportional to size. Directly proportional to charge and inversely proportional to size. If the charge density is higher, it will be forming a higher, stronger ionic bond. That's the point. Lattice enthalpy is over there. Now the next topic is coming is hydration enthalpy. Hydration enthalpy. What is hydration enthalpy? Hydration itself is meaning that addition of water. If an ionic compound is added with water, what is happening? Water molecule will be surrounding the respective ions, and this surrounding of water molecule in the ionic compound solution to their respective ions is what we called as hydration. And when each water molecule is attracting the respective ion, energy will be releasing. That energy is called as hydration energy. I will be explaining it. Just give me a minute. Yeah, I will be explaining hydration energy with an example. Suppose I am having an NaCl compound. This is an ionic compound, right? It is having Na plus and Cl minus. Ions. Now I am going to add water into it. When I add water, the positive part, okay, yeah, then okay, the negative part of water, that is oxygen is delta negative. This will be attracting the positive part of the ionic compound. Yes or no? Yes. This delta negative part will be attracting the positive part of ionic compound, that is Na plus, and the positive part of water, that is hydrogen. This is having delta positive. This will be attracting the negative part of ionic compound. Now this is what we call it as hydration. When there is a single attraction, or whenever there is an attraction, at that time energy will be releasing. That energy is called as hydration energy. That energy is called as hydration energy. Now is it clear? Yes, thank you. And this hydration energy is directly proportional to directly proportional to charge and inversely proportional to the size. Directly proportional to charge and inversely proportional to size, and it is directly proportional to solubility, and it is directly proportional to solubility. Why it is directly proportional to solubility? When hydration energy is very higher, what is happening? There will be breakage of sodium and chlorine. There will be breakage of chlorine and sodium, and that breakage is what called as solubility. Okay, that is each ions will be soluble in the water. Okay, and it is directly proportional to charge and inversely proportional to size. And one more thing about solubility I want to say is lattice enthalpy. Lattice enthalpy is inversely proportional to, okay, solubility is inversely proportional to lattice enthalpy. Solubility is inversely proportional to lattice enthalpy, and you can see the equation of lattice enthalpy and hydration enthalpy, both are same. Then how we can decide the solubility? We will be deciding solubility if, that is, a compound is soluble in water. A compound is soluble in water if hydration enthalpy is greater than which enthalpy? Lattice enthalpy. This is the point. If I can say a compound is soluble in water only if hydration enthalpy is greater than lattice enthalpy, because you will be getting a confusion that hydration energy and lattice energy both are directly proportional to charge and inversely proportional to charge, and both are not matching with the solubility. So there will be a confusion at that time. On that confusion can be cleared by understanding that a compound will be soluble if hydration energy is greater than lattice enthalpy. Understood? If you understood, give me thumbs up or some emojis, some reactions. Yes, thank you everyone. Yes, well done, well done. Now we can go into the application of hydration energy, how the question is coming from this part. I am going to give you a question. Yeah, okay, leave about this one. I am going to give you a question. Arrange the following in the order of size. Arrange the following in the order of size. That is lithium, aqueous, sodium aqueous, potassium aqueous, rubidium aqueous. What is the order of size? Which is having highest size? I want answer from everyone. Which is having highest size? Lithium or rubidium? Which is having highest size? Who is going to give me the answer?
Rubidium.
Rubidium is having highest size.
Rubidium.
Yes. Sangeeta is saying rubidium is having highest size. Anyone else is saying any other answer?
Lithium.
Lithium. Prathamesh is saying lithium. Yes. Anyone else? Okay, I understood. Yeah, here is a mistake that you will be doing. Here the size is, they are not asking about the normal gaseous ionic size. They are asking about the size of the hydrated ion. This aqueous is mentioning. What does this aqueous is mentioning? These ions are hydrated. These ions are hydrated. Among these, higher the hydration energy, higher will be the size of hydrated ion. Yes, higher will be the size of hydrated ion. Now among all these ions, tell me which ion is having highest hydration energy. highest hydration energy? Tell me. Hydration energy is directly proportional to charge and inversely proportional to size. Among all these, charge is same, size is different. Lower the size, higher will be the hydration energy. Lower the size, higher will be the hydration energy. Among these, lithium is having the lowest size, so it is having highest hydration energy. And highest hydration energy means highest will be the size of hydrated ion. That is, if a ion have highest hydration energy, more water molecule will be surrounding to it. If more water molecule is surrounding to it, the size will increases, right? And here that size is only asking here that size is only asking. So this is the point I want to take a note of it. Few more point is there about this one, that is about mobility and conductivity, that I will be discussing in the next class. I know that now it's the time for lunch. So guys, this is all about this is all about the starting of this chapter. Next class we will be continuing about this chapter. All of you can go for lunch. Have a nice day. Prepare very well. We'll be seeing the remaining part of this chapter in the next class. Yes, thank you everyone.